Hello, class. I hope everybody is faring the stay-at-home sort of order pretty well right now. Today, I'm going to spend a little time clarifying some of the issues that arise when we're talking about statistics, particularly a lot of talking about inferential statistics here. Um, Rightfully so, there are some questions. Okay. Admittedly, we're only going over this at a relatively superficial level. Okay, and I will apologize about that, but to get a much more advanced level would take a whole class rather than just a few lectures dedicated to it. However, the goal is for you guys to be educated consumers and be able to understand studies that come about via statistics. Okay. There are three main themes that I saw out of the discussion questions. And I'll apologize if your discussion question is not covered with this. If it isn't and you really do want the answer, which you asked it, so apparently you do, please reach out and we can go over this individually. But I want to try to get some of the main pieces that are kind of sticking points for a large number of folks. Okay. These sticking points are number one. Okay. When would you use this stuff? Okay, that's reasonable. And it's a good thing for me to try to explain to you. Okay, and I'll keep trying. I'll keep trying. Number two, how the heck do I calculate variance? Okay, that's reasonable. That is perfectly reasonable. And we're going to go over that. And number three, and again, I've always said if I don't succeed, I'll keep trying. I'm going to try once again to try to explain two different issues, one of which is new, which is the difference between one-tailed and two-tailed tests. Okay, this hopefully should be relatively simple. The other issue is, and it's a repeat of last time, I'm going to try to better explain type 1 and type 2 error. Okay, so with that, let's get moving on this. Okay, so you've done a study. Okay, you've done a really cool study, and we're excited about the fact that you've conducted a study. Okay, when it comes time to analyze and look at the data, a major piece of it is, well, how is it that you did your study? So if you didn't done a single case design, kind of the stuff that we were talking about before the break, typically the way that would be examined or looked at is in the context of graphical analysis, okay? Judgment of differences that will or will not be apparent on a graph, okay? Statistics actually, in many cases, are not even appropriate in these instances. Because one of the things that statistics often need is that each data point needs to be independent of the other. And as you've seen in the context of putting together single case designs and our examples and thinking it through, so on and so forth, oftentimes data on one session are actually kind of dependent on data on another. So you're often seeing trends from session to session. Okay, that often makes it very difficult to look at this stuff in the context of single subject design in the context of statistics. However, there are still statistics that are involved in a single case design. So oftentimes you will want to aggregate data. Okay, so you might want to show the average number of problematic behaviors in each condition of an analog functional analysis. So you've set up a situation where you set the stage in many different ways for children to behave in these different circumstances. And in these different circumstances, you're basically measuring the amount of problematic behavior, with the theory being that the circumstance in which you see highest rates of problematic behavior, particularly compared to control, are the circumstances that mirror why individuals are doing it. So if kids engage in problematic behavior a whole lot of times, when the only thing they get is attention for doing it, but they won't do that when they're played with and so on and so forth, it's reasonable to say they're doing it for attention. Okay, but if you're looking at the average in each of those conditions, anytime you average something, you need to provide some measure of variability. Okay, so as we were doing in our activity, you could do variance, standard deviation we did in our activity is a pretty common way to represent the differences between conditions. okay, or the variability that you see within conditions, okay? So that's how some statistics interact with single case designs. However, what we've been talking about this week has a lot to do with group designs. Okay, so now you're not in the circumstance where people are going to act as their own control. You're not in the circumstance when you have the luxury of running all these baseline conditions for an individual and then comparing their responding and treatment to that. Instead, the best that you can do is you can compare individuals who received treatment versus individuals who didn't, that control group, okay? It's actually a very common arrangement. In fact, actually many areas of science exclusively use these, and you need to understand these because so many other areas of science exclusively use these. If you want to be able to understand if the data that they're presenting to you have any value or not, you have to understand this stuff, okay? And so those are the instances where you need to think about statistics. Okay, let's walk slowly into this. Okay, as I was talking about, when you're averaging these functional analysis conditions, the average problematic behavior in each of the conditions, then you have to calculate variability because they're aggregated. Okay, and I said that what you want to do is you want to compare the amount of, you want to see which condition has the highest rates of problematic behavior. Okay. This is not all that different than group sort of circumstance. Now, let's say instead of having each individual experience these different conditions, you have individuals under, you have groups of individuals who experience each of these different conditions. They only experience one condition. And what you want to look at is, under what condition do you see the highest rates of problematic behavior? And then you're going to say, hey, this problematic behavior is related to this particular consequence. Okay? We can talk about the error in my ways here, but let's first at least talk about this for a statistical example. Okay, now you've collected all your data, you have your averages, and you have your variability around those averages. And what you're comparing, just as before, is how if the differences between conditions are bigger than the differences within conditions. So the differences between conditions. So is the attention condition, how much higher is the attention condition than the control condition? As I was just saying a second ago. Okay? If that difference is bigger than the amount of variability you see within each of those conditions, you will say that there's a difference. However, even if one condition is higher than the other, if there's so much variability, you're not going to say that there's a difference. Okay? That's the heart of statistics. Okay? So anytime you set up a group design, so let's say I decided that I wanted to know about if I would see differential amounts of weight loss if I had individuals exercise every day, or if I had individuals just be as sedentary as they wanted to. Okay, I can measure these. I can measure their weight at the beginning of the experiment. Then I can measure their weight at the end of the experiment. So let's say I have them do 6 weeks of either exercise or not. And then actually, to be fair, I probably would look at the change from baseline to treatment, to the end of treatment, so how much weight they lost. And I would compare the amount of weight lost in the individuals who exercised every day versus those who were sedentary. Okay, now what I have here is some degree of weight loss, and it's probably going to vary from person to person, so you'll see some variability there in our condition that was receiving our exercise, the amount of weight loss. And then odds are they didn't really lose very much weight in the other one. What I'm looking at is there a bigger difference between exercise versus not than there is based on individual differences that you see within people. Okay, the test that you'd use for that is just a simple t-test. Okay, a question came up, and it's a rightful question. Is a t-test more accurate than ANOVA? And actually, the answer is no. They're essentially the same test. And a t-test is a special case of the ANOVA that only works when there's two groups. If there's a third group, so let's say I had compared those two groups to another group from which I had engaged in a very regimented diet. So I compare individuals who exercise every day for 6 weeks, those who sit on the couch and have no other specifications, and those who are on a regimented diet. Okay. Now that there are 3 conditions, that would be considered when you would use an ANOVA. Okay, and the reason that it would be the ANOVA is it's a continuous variable. So you could lose 1 pound, 2 pounds, you could lose 1.2 pounds. It's a continuous amount that you could have lost. Okay, and that you have more than 2 groups. Okay, you could have 100 groups in an ANOVA. If you had enough people, you might be able to see something. Okay, but an ANOVA is when you're looking at a continuous variable, for example, in this case, the amount of weight lost, versus discrete groups. So we have 3, in this instance, we have 3 discrete groups. That's when you'd use an ANOVA. Okay, and those are, so t-tests and ANOVAs are some of the most common tests that you would see within group designs. Okay, another one that we had to cover, because it's also very common, and it works largely on the same logic, is the chi-square test. Okay, and what you're looking at there is the distribution amongst 2 different outcomes the same. Okay, so if I had basically categorical variables, so like yes or no is, it's either yes or it's no. Okay, if I were to flip a coin and yes and no's were evenly distributed, you'd expect about 50-50 in the population. And when you're looking at a chi-square, you're looking to see, does it actually match that distribution? So if I all of a sudden saw that out of 100 coin flips, 75 of them were heads, that would not fit what the expected distribution is. So you would expect to see close to a 50-50 distribution. That would be aberrant. That would be considered significantly different. Okay? And so chi-square is basically just seen are the distributions as you would expect them to be. Okay? In the context of a group design, you'd want to see if the distributions are the same in the control and the test group. Okay? Because all else being equal, they should be the same. Okay? Those are the most prototypical sort of tests and why you would look at them. Okay? Various aspects of these can tell you something. Okay? So there were a number of questions that came up surrounding the alpha value, so your p-value. Okay? The alpha value is the value at which you will say anything higher than this alpha, or anything lower than this alpha value is statistically significant. Okay, and an astute question came up and said, well, if the researcher chooses the alpha value, then whoever decides is something significant. They do choose the alpha value, but more times than not, it's almost universally the same, and that is the alpha value is almost universally 0.05. Okay, so the alpha value is almost always 0.05. And if it varies, they have to tell you that it varied, and you're going to kind of wonder, why did you make it that? And particularly if you made it less stringent. So it would be reasonable to assume that it would be weird if someone chose a p-value to accept as statistically significant that's relatively friendly. And you'd look at that with skepticism. Okay, so what we're teaching you in this class in terms of statistics is how you can look at other people's studies and go, I don't know, that just seems off. So if they accepted a p-value of like 0.10, so they'd allow things to be off by chance 10% of the time, that just seems a little weird. Okay, if you see that they use a continuous variable, okay, so like I said, was talking about weight loss. This is a continuous variable, but they use a chi-squared analysis. That's just not the right sort of thing, okay? Or, they use there's a categorical variable, so it's not continuous. So it could be yes, no, or it could be, different colors of M&Ms or something like that. And they use an ANOVA. They didn't do the right thing, okay? So it gives you reasons to be skeptical of it. For one, did they know what they were doing? Or for two, are they trying to hide something? None of these outcomes are particularly good. Okay, and so these are some of the tests that you'd use and why would you use them. Okay, moving on to the next major issue, and that is the issue surrounding calculating variance. And we had an activity on this, so it makes sense that people would have some concerns about it. Let me